Hello and welcome to our last lab, Carbon in the Forest, or the Wildfire Lab. This series of related activities is intended to use satellite image analysis and extend the analysis into the atmosphere and some environmental impacts. Carbon is a fundamental building block of life on our planet and can be found in organisms all around us. Many scientists are interested in studying how carbon moves through the environment and the creatures and plants that live in different ecosystems. This is a biogeochemical cycle, if you remember from Chapter 1. In this exercise, you will analyze satellite imagery and gauge some of the environmental impacts of a large forest fire. So lab objectives: 1, determine how much carbon is sequestered in a tree and forests. 2, determine how much carbon is released in a fire. And so part 1, determining carbon sequestered in a tree. I've made up a hypothetical study area. And I've given you the diameter of the tree at 1.37 meters. And the height of the tree, I haven't given you the height, but I've given you the angle, this angle here, A, to determine the height of the tree. And so I've given you these measurements. If you want to, you can totally do your own measurements on your own in your free time. But I've just given you some hypothetical field data so that we can all get the same answers. And so this explains how to calculate the height of a tree given the angle and the eye height of the person measuring the tree. That's the y variable. And for y, we're going to use 1.6 meters as our eye height. You might be taller or shorter, but I'm just using 1.6 meters as eye height. And to get this height of the tree, this whole height, use this equation here. Right? So use tangent A, this angle here, which I've given you, times B, this length, which I've also given you, plus y, which I've given you. And so using that equation, you get height. And you can, if you're unable to do tangent angle A on a calculator, you can use the appendix at the end of the lab to get tangent A. I'll show you real quick. Yep. Down here at the end. So here's the angle, and there's the tangent. Okay. Back up here. So you do all these calculations, and you're guided very well through each of the questions and what to do. You do these calculations, and you record your calculations in this chart right here. And so I've given you the diameter of the tree, the species of the tree, the age of the tree, and the angle. And so you look up or calculate the tangent angle, and then you're given, oh, I need to fill in, but I'll be giving you the length B, how far away the angle was taken from the tree, and you already have the height of eye level for the person measuring the angle, which is 1.6 meters, and then you can figure out the height. And then you walked through how to calculate each of the other things in the questions up here. So you just walk on through doing all those, and then you get to play with the data that you've created. Things like how much carbon is sequestered on the plot, and then how much CO2, and you get to extend your estimates to what might happen or the amount of carbon that might be released in the Big Burn of 1910. It's a famous wildfire. If one of you guys want to do your class project on that Big Burn wildfire of 1910, I don't mind if you do. That's very interesting. And then get to play with how much carbon might have been released in the Yellowstone National Park wildfire that happened in 1988, which is also another great class project topic. And so here's the wildfire area. It's outlined in this black and white dashed line. And you've got a vegetation legend with black being healthy vegetation and white being no vegetation. So this is in 1987 before the Yellowstone burn. And here is 1989 after the Yellowstone burn. Yeah, burned a lot of vegetation. And you can calculate the area burned, which will help with calculating how much carbon was released. And this is 10 years after the fire, and so you get to estimate how much has recovered and then how much CO2 has been sequestered out of the atmosphere with that regrowing vegetation. And then this is 20 years later in 2008. And then there's some general climate questions associated with carbon in the atmosphere. And here's the Mauna Loa record. And some questions about that. So I think this lab is a little bit more complex than the other labs. Though with thinking about it, I think you can calculate all the different answers and really get to play with how much carbon is sequestered in our forests and how that relates to industrial emissions. In particular, the lab asks several questions comparing forest carbon content with cars. Let's see if I can find that. Oh, it must be up here. Am I making you dizzy? Let me find cars. Here we go. So it's page 4. And so we're comparing emissions of cars with wildfire emissions of carbon dioxide. And so we get to we'll play with those numbers and really see how much carbon is released into the atmosphere with car emissions and with wildfires. Anyway, if you have questions, feel free to email me. I will answer your questions. And yeah, your last lab. Woohoo! You're almost done. Keep up the good work. Don't stop now. Anyway, I'll talk to you again. Bye.